Hello everyone. Today we'll be looking at the model topology for routing and switching. So this is the model topology we'll be working on today. This topology has many tasks that we'll have to perform. So let us divide the topology into three different sections. Consider this section having three switches as section 1. In this section, in switch 1, we'll have to display a message XYZ and the port FA05 should show switchport security. Coming to the second switch, we'll have to show SSH and the port FA0 bar 3 should show Portfast. And this entire section should showcase VLAN. Coming to the second section, the second section consists of the two switches, and in this section, we'll have to perform LACP between the two ports FA0 bar 20 and 21, and in both the switches, show that LACP is enabled. Coming to the final section, we have to assign the PCs with IP addresses dynamically using DHCP. So this concludes the topology. Now let's move on to the actual construction using packet tracer. Okay, so now let's begin with the first section of the topology. So the first section of the topology has three switches 2960. So let us place them accordingly. It also consists a router so that it forms a VLAN. Yeah. Okay, so now we have two PCs for the bottom two switches. So let's add them to. Right. So now let's start connecting all the devices. So let this PC be connected to FA0 bar 3, the second PC to FA0 bar 4. Let the third PC be connected to FA0 bar 5 of the switch, and let the final PC be connected to FA0 bar 6 of the first. Right. So now let's start connecting the switches. So for switches, as you can see, we'll be using a copper crossover. So let us connect FA0 bar 1 to FA0 bar 1 and FA0 bar 2 to FA0 bar 2. And finally, we'll connect the router to the switch. Geek 0 bar 1. Okay, so the first section of the topology is constructed. So let us move on to the first task. As you can see in the model topology, the first task would be to display the message XYZ. So let's begin with that. Right. So we go to the switch CLI. So let's start coding. So first we'll enable it, and now we shall do config terminal. Let us change the host name as well. So let us change the host name to S1, and now we shall display the banner. So the banner is displayed using the code banner MOTD $sign XYZ and $. So that's it. This should enable the banner display. So let us check once again. So let's check once more, and as you can see that a message XYZ is displayed. So this concludes the message of the day symbol. So now the second task. The second task would be to enable switchport security and show shutdown violation. So let us move on to that. So for that, enable config t, and then the port number. The port number, as you can see, is FA0 bar 5. So let us move with that. So it will be interface FA0 bar 5 switch port mode access switch port. security, switchport, port security, switchport port security, and switchport port security maximum 1, switchport port security MAC address sticky, and switchport port security violation shutdown. So we'll move with no shutdown, exit, exit. So let us check whether the shutdown uh, violation actually works. But for that, we need to assign IP addresses to all the PCs initially. So let us address IP addresses. So let the first IP address, first device have IP address 192.168.10.1. The subnet mask is assigned by itself. Then the second 192.168.20.1. Then the third PC be allotted 192.168.10.2, and the final PC will have 192.168.10.3. Yes. So IP addresses have been assigned. So now let us see whether the shutdown violation is working or not. So for that, let us add a intruder PC. As you can see, our intruder PC has been added. Now let us add a IP address for the intruder PC. Right? So 120.192.168.10.10, and let us change the ports now. So let us take a wire having the PC to the fifth port, FA0/5. Let us see if packets are being transferred. As you can see, when the packet was sent, the port has become shut down. The red line indicates that the entire line port has been shut down, and this shows that the switchport security violation is working. Right? So let us know that now. Right? So let us add the normal piece. Okay, so now let's move on to the second switch. The second switch, what are the tasks we'll have to perform? Let us. So the first task would be to perform an SSH, and the second task would be to perform Portfast in the port FA0/3. So first let us move on to SSH. Shall we? Yes. So let us this right. So let us start with the first enable config C, right, and then we'll move with interface VLAN 1 IP address 192.168.1.250 and a subnet mask of 255.255.255.0, right? And then we'll go on with no shutdown and exit. Now let us give a username ABE and a secret code of 111. Sorry, the name Yes, is the name of ABCD and secret code 111. Then we'll give the IP domain name nhc.com crypto generate RS. So here we'll be entering the number as 1024. 1024, and then now we'll write like pty0 space 4, then login local transport input SSH secure timeout, then exit. So this is how we'll move on with SSH, and for verifying it, we'll go to the we'll go to any one of the PC's command prompt and type IP. We'll type the SSH -L and the IP address of the switch. Okay, now let us move on to the second task. The second task would be port fast in the port FA0 bar 3. So let us move with that, right? So switch 1 now and yeah. So for port fast, we'll go with enable config C, and the interface is FA0 bar 3 spanning tree. Portfast, Portfast, and then we'll have spanning tree PPDU card enable. As you can see, Portfast instruction is very simple, just 3 codes, and that's it. So PPDU card enable. So let us see if it is enabled, right? Yes. So for that, let us take a PC and let us connect the port of FA0 by 3 to the third. So FA0 bar 3. As you can see, the color turns immediately green, and this shows that port pass has been enabled properly, right? So let us move on. So let us bring back the connection to its normal stage. 0 bar 3. So now let us move on to the third task. As you can see, the third task would be to enable a VLAN to the entire section. Okay, so the first PC would have a VLAN 10, a second PC would have VLAN 20, third and fourth PC will have VLAN 10 respectively. So let us move to that. So for that, let us go to the first switch, enable config T, config T. So now let us move it interface FA0 bar 3. I'm sorry. We haven't given the VLANs. So VLAN 10, name first, VLAN 20, name second. So we'll exit the VLAN, and now we'll start assigning the VLANs to the interface. So interface FA0 bar 3, switchport mode access, switchport access, VLAN 10. Now let us put this, and then interface FA0 bar 4, we'll have switchport mode access, and we'll have switchport access VLAN 20, right? And then we exit this as well. And next we'll have interface range, as since the other two ports have consecutively assigned VLAN 10, we'll go with interface range. So interface range FA 0 bar 5 to 6, 5 to 6. Then we have switchport mode access, switchport access VLAN 10, and exit. Then we'll assign the port number FA0 bar 2 as a trunk port. So for that, we'll go with interface FA0 bar 2, FA0 bar 2, switch port on trunk, and exit. As you can see, we'll be going with this code for all the three switches, and the switch port mode trunks will change according to the uh, port to which the switches are connected to the other switches, right? So let us move on to the second switch. So for second switch, we'll go with VLAN, go with assigning the VLAN 10 first, VLAN 20 in second. We shall exit the VLAN, interface A0 bar 3, port mode access, switch port access, VLAN 10, and exit. Next, we'll move with interface A0 bar 4, switch port mode access, VLAN 20. Okay? And then we'll have interface range FA0 bar 3, FA0 bar 5 to 6. Switch port mode access, switch port access VLAN 10, and then you put exit. And in this switch, the first switch is connected to the second switch in FA0 bar 1, so we'll consider this as a mode trunk, right? So interface FA0 bar 1, switch port mode trunk, and exit, right? So that has been done, and now we'll move to the final switch. So in the final switch, we'll follow the same procedures. Equal config t. We'll change the host name as well for this, host name 3, and now we'll go with the VLAN assignment. So VLAN 10 first, VLAN 20 in second, and exit. Now for the interface FA0 bar 3, switch port mode access, switch port access, VLAN 10, switch port access. We'll exit this now. Next we'll move to the interface FA0 bar 4, right? Now we'll move to switch port mode access, VLAN 20, and we'll exit this interface. And then for the final interface range A0 bar 5 to 6, switch port port, access VLAN 10, exit. Okay. So in this switch, we can see that the ports FA0 bar 1 and 0 bar 2 are connected to the other two switches. So we'll consider these two ports as a trunk port. So for that, we'll go with interface range FA0 bar 1 to 2 switch port mode trunk and exit. And in this switch as well, we have a router connected to this as well. So we'll have to convert the router port as well into a mode trunk. So we'll go with that too. So interface gig 0 bar 1 switch port mode trunk and exit. Yes. So this concludes the switches configuration. Now let us move on to the routers configuration, shall we? Yes. So router, we'll go with we'll go enable config T. So let us change the host name as well. It will be easy for us to move ahead. R1. So now we'll go interface gig 0 bar 0. Now shut down and exit. Now let us go to the sub interfaces. So interface gig 0 bar 0.10 encapsulation dot 1 q q and q10 dot on q10 IP address 192.168.10.100 the subnet mask 255.255.255.0. Yes, and no shutdown. Exit. Now let us move on to the second interface. 0/0.20 encapsulation dot 1q20 and we'll assign this an IP address of 192.168.20.100 255.255.255.0 as a subnet mask. No shutdown. And exit. Right? So I think this concludes all the configuration. So start checking for packet transfer, we have to make sure that all the PCs have been assigned a proper gateway because we tend to generally miss out the gateway. So let me indicate the VLAN, right? So we'll color. Right. So we'll label all the VLAN 10s as red color. VLAN 10, VLAN 10, and VLAN 10, and all the VLANs as and all the VLAN 20s will move with a blue color, right? Okay. Right. So now we know which VLANs have assigned to which P. Now let us move on with assigning the default gateway. So for this, the default gateway will be 192.168.10.100. For the second PC, as it is a VLAN 20, we'll assign it with the 192.168.20.100 gateway. the other two PCs belong to VLAN 10, so their gateways would be respectively 192.168.10.100, sorry, 92.168.10.100, and the same would repeat in the final PC. Yes, 192.168.10.100. So all the configurations have been done. Now let us see whether the packets are being transferred. Right. So PC0 to PC1 successful. Since it is in the same VLAN, it will be successful. But to move from PC VLAN 10 to VLAN 20. Initially, in the first try, all the packet transfers fail, but in the second try, we should have a successful transfer. Yes, as you can see, a successful transfer has been taken place. So, and here too, we'll have initially a failed transfer. Oh, no, we have a successful transfer as well. So, yeah, initially only once it will fail, and the other times we'll get a successful packet transfer. So, this concludes the initial section of the topology. Now, let us move on to the second section. The second section. Okay, so in the second section, you can see here we have that we'll have to connect the ports FA0 bar 20 and 21, and we'll have to perform an LACP function. So let us move on to the LACP function, shall we? So let us go and get the port 2960, right? And now let us connect the switches. Since we are interconnecting switches, we'll have to use the copper crossover. So the ports are FA0 bar 20 and FA0 bar 21, right? Yes. So now that we have connected them, let us move on to their configuration. So we'll be guided to a config mode, and then we'll move on to interface range FA0 bar 20 to 21, and we'll connect this ports to a mode trunk, switch port, mode trunk, and exit. Right. Now let us move on to the assigning the LACPs. So here we'll go with the desirable mode. So interface range FA0 bar 20 to 21. We'll shut down the ports. We'll shut down the ports, and then we'll go with channel group 1 and mode as desirable. As you can see, now we'll now shut down the port. Exit. Now we'll interface port channel 1. Channel 1. This was a port channel that was created by the channel group 1 mode desirable. And now we'll have switch port, mode trunk, and we'll exit. Exit again. Right. So in order to see whether the LACP has been performed, we'll go with the command show ether channel summary. Right. As you can see, so PGP has been enabled in both the ports FA20 and FA21. So now that we are done with this third switch, let us move on to the right hand switch and perform the same task here as well. So here we'll go with enable config T. Let us change the host name to S4, and now let us start with assigning the mode trunks. Interface range FA0 bar 20 to 21 switch port mode trunk. Yes. mode trunk, and then exit interface range a 0 bar 20 to 21. Yeah, shut down this, shut down, shut down, and we have channel group 1 mode desirable, then we shut down the port, then exit. Now we again interface the port channel created by the channel group, interface port channel 1, switch port, mode trunk, then exit. So now let us see whether PHP has been enabled here as well. So for that we'll use the command show at the channel summary. Yes, so you can see here the PHP has been enabled as well. So the PHP task is also completed. So we are completed with 3/4 of the topology. Now let's move on to the final topology. So what is the final topology? Final section of the topology. So the final section will have 3 PCs and a router, and we'll have to assign the PCs with IP addresses dynamically. That we'll have to use DHCP operation. So let us move with that. Right. For that, let us add 3 PCs and a router. Right? Yes. So for that, add a router 1941 and 3 PCs. 1, PC2 and PC3. So let us connect the PCs for that. FA0 bar 1, FA0 bar 2, and FA0 bar 3. Let us connect the router to the switch. The router has been connected. So now let us configure the router so that we can assign the IP addresses to the PC. Now let us enable config T. So the interface gig 0 bar 0. Let us assign an IP address of 192.168.1.100 and 255.255.255.0. Yes, IP address is assigned, so we'll now shut down it. And then exit. Now IP DHCP pool CCNC, and now we'll go with network address as 192.168.1.0, subnet mask of 255.255.255.0, and the default router address is 192.168.100, and the DNS server we shall assign it with an IP address of 92.168.1.50. So let us exclude few addresses. So let us consider two addresses 1 and 10. So for that we'll have to type in DHCP excluded address 192.168.1.1, 192.168.1.10. Right? And now let us also exclude the IP addresses 100 and 100 because it is the IP address of the router, so we do not want it to be assigned to any other PC. So let us that do, and we'll exclude the IP address of the DNS server as well. Yes. So the IP address DHCP configuration is done. Let us exit from this. Yes. So now let us move on to the PC. So PCs, you can see. So in the PCs, the IP address haven't been assigned yet. So for dynamically assigning the PCs, you can see here DHCP option is present. So we click on it, the IP address is requesting, and you can see that IP address has been assigned. So the IP address for here is 192.168.1.12. So let us move to the second PC and repeat the same procedure. Click on DHCP and it is requesting for IP address, and we have got the IP address, so it is 192.168.1.13. So we'll move to the third PC. IP configuration, DHCP has been assigned, and we got it 192.168.1.11. So all the three PCs have been assigned DHCP. So this concludes our topology. The topology seems complex, but it is actually a quite simple topology. It can be done within an hour or so. So please do practice, and if you have any doubts, please do contact your teachers and get it clear. Thank you.